class? How are you doing? So, today's topic. So we're going to talk on implicit differentiation, and on our previous lessons we've handled different methods of differentiation, and I just want us to recall on this. Let me give an example of a function. You see, given y is equals to 2x plus 4, we say that this function is explicit. Why? Because y is fully represented by x. Or I can say y is expressed fully in terms of x. So you may come across situations like, let's say z is given by x cubed y. So you see how these two functions are different. So we say this one is explicit because y is expressed fully by x. But this one, we say that it is an implicit function because it is expressed by more than one variable. So now we can understand the meaning of implicit differentiation. Yeah, so we can go ahead to tackle one example so that we can see how we go about it. Let's say, for example, you have been told differentiate y power 4 with respect to x. So given a function y raised to 4, and you have been told to differentiate this function with respect to x. So this function has no any variable x within it. So how do you go about it? You just use the normal power rule of differentiation. You differentiate it normally, and then you add a component of the variable x. So how do you differentiate this normally? Do you have any idea? Just use the power rule. Can you recall?
Can I give them?
Yes, just give the answer.
Then it's 4y.
4y cubed. But we have been told to differentiate this function with respect to x. So we should have a variable x here. We're adding dy dx. This is a very simple example. Let's go to a more complex example. Say a logarithmic function. Let's say sine 2p. And then we've been told to differentiate with respect to y. So once again, these are logarithmic functions. So you know how to go about a logarithmic function differentiating. Does anyone have an idea? Differentiating a logarithmic function. Sine, the derivative of sine. So my answer is 2 cosine 2b. Sindio? But you couldn't differentiate with respect to? So we have the variable. Now Now this function has a function b. So you write dp d. That's it. So let me have another example, maybe a complex one. Let's say given z is equals to x squared y cubed. And you've been told to differentiate this function with respect to y. You've been told to differentiate this function with respect to y. Now, keeping in mind that you've tackled all the methods of differentiation, that is the product rule, quotient rule, the chain rule. So I know you can recall them. Now, when given such a function, z is a function of two variables that are connected by a multiplication sign. So, what comes into your mind when you come across this function? Product rule. So I'll take my x to be u and my y to be v. I know you know the formula. For those who don't know, you can use our teaching SMP mathematical table. It's in there. So those statements self in the formula. So let us find du dx here. Du dx will be 2. But you know we are differentiating this function with respect to y. And this is a variable x. It does not any component of y. So we add dx. The variable is x. We add dx, dy. Now come to your variable v. Y continue. Let us find dv. This is the du dy. Sorry. This is du dy. Let us come to our variable v. We have been told to differentiate with respect to y. So dv dy will be 3y. This is a variable y. So at one any component y because there any y. So let us recall our formula, our product rule formula. Our product formula dy dz. Now it will be dz dy. So because the function is z, is given by z, x cubed. So we go to differentiate with respect to y. Now it will be dz dy is given by the product rule. U dv plus v du. What is my u? X squared. X squared. What is my dv? Here. 3y squared, 3y squared. What is my v? Y cubed. What is my d? 2x dx dy. 2x dx dy. Then you can rearrange it. In fact, this will be 3x squared y squared plus 2x y cubed dx dy. And that is it. That is how we go about these implicit functions. So when coming across a question, you should look at the nature of the question. Let's say this given y is equals to 2x plus 4. We say this to be an explicit function. Explicit. And when y is fully expressed with more than one variable, we call that function to be implicit. So any question to there? So I'll send out an assignment for you guys to tackle. But the common resource book normally used is the John Bard, which is one edition. Unless you have any query? Any query? So, what a question. Do you have my class attendance? Yes, please hold it.
But I have a concern.
You have a concern?
Which office do I locate?
Which office? Room 121. If you have any problem, my biggest problem, you just come. Okay?
Is there a
Is there a tea? No problem. That's not an issue. just come and say problems and solve it. Okay? Guys, thank you.